Hello everyone, this is lecture 7 for thermal physics. In the last lecture we have completed the Maxwell-Boltzmann and speed distribution. Today we will start the mean free path and the transport phenomena. In this we will study how to calculate the mean free path and what is it, and then we will see that what is relaxation time. So when there are gas molecules, they are moving rapidly, then amount of the distance traveled by a particle or the molecules without any collision is called the mean free path. So we can't calculate it directly, so we have to take an average value. And same, there is a time between this collision, that is called the mean free time or the relaxation time. So we need to take the average of that also. So let's see how can we calculate this. So there are two methods to calculate this. First, let me give you this. Consider gas having large number of molecules. Mass of a molecule is m and diameter of each molecule is d. What is our objective? What is the average time between successive collisions? So that is called the mean collision time, scattering time or the relaxation time, all are the same. And now there are two methods to calculate them or to evaluate them. These are zeroth order approximation. In this, we consider that only one particle is moving, others are at rest, and this is moving at the velocity v. So molecules under consideration is traveling at speed v, all other molecules at rest. So this is what we do in this zeroth order approximation. Then we will study the first order approximation. There we will see that all molecules are moving with an average velocity. So we'll calculate both these mean free path and the relaxation time by both methods, and we'll see what is the difference. So let's today we will see the zeroth order. So let's see. So mean collision time. So in this, only molecule under consideration is moving with speed v. So I told you this was the approximation here. And what is the meaning of this? Relative speed of this molecule with respect to others will be v. Means all others are rest. So relative velocity of this particle which is under consideration will be v. Now see, if this particle is moving, then what is the influence? Means area of influence. Means what is the probability that it will collide? So when the particle is in this range, means this is your d by 2 and this is d by 2 and this is your complete particle. So this will collide when these particles will come in this range. Only in this range this will collide. So that's why we call this as tube of influence. Means when particle come in this tube range, then there will be maximum probability that it will collide definitely. So that's why we calculate this cross section area, and we call that as collision cross section. And see, if this diameter is d, then this complete circle have the radius as this d. It will be equal to this. So that's why the cross section will be pi d square. Here this radius is d for this complete circle, and we call this as cross section, collision cross section. So must remember, this will be pi d square and we saw it by sigma. So where this d is the diameter of the gas molecules, must remember. Now what is the means in dt time, what is the volume covered by this particle or the molecule? That will be v dt, that is the distance traveled, multiply this area of cross section will give you volume. So in time dt, the volume swept by this molecule will be sigma v dt. Now if number density, that is number of particles or number of molecules per unit volume, is small n, then this will be volume. So n multiply this will give you a total number of particles in that path v dt. So the number of molecules contained in a cylinder of volume sigma v dt will be n sigma v dt. So these are your molecules which will be possible to collide, means which will be lying in this range. That's why, and we can call it as probability of collision also, because the more number of molecules will be lying in this range, more will the probability that it will collide. So number of collisions in dt will be this. These will be your number of collisions equal to the number of molecules available there. In time dt, the probability that a collision take place inside a cylinder of volume sigma v dt is equal to n sigma v dt. So we assume this probability equal to this. So we are assuming this time because we know that more the particles, more will be the chances. So that's why we are saying that this will be a probability also. The same number will be a probability. In the last we will check that if this is actually probability or not by verifying these laws, that total sum is 1 or not. So now we are just saying that more the number of particles, more with the chances of means collision. That's why this is your probability. Now let's assume that Pt is representing probability that a molecule does not collide up to time t. So if this probability represents that up to time t, the particle will not collide, then in the t plus dt time, we can write from the calculus this thing, because p d plus dt minus pt divided by dt will give you dp by dt. This is a simple expression. Now what is p t plus dt? It is the probability that the particle will not collide in dt time also. Means after t time, the dt in dt time, the particle will not collide. This will give you that probability. So the particle not colliding at t time and not colliding at t plus dt time. So these are two independent events. So we know in the probability that independent theorem that that will be the simply means pt plus dt will be equal to means that will be just the product of pt and in the dt time. So p t plus dt is nothing but the probability of not colliding at t and not colliding at dt time. So this will be simply product of these two for this. Okay, that is the probability of independent events. You must know about that. So probability that a molecule does not collide up to time t multiplied by probability that it does not collide in subsequent time dt also. So that will be equal to pd plus t plus dt equal to pt not colliding at t time. Now we know probability of it is colliding at dt time is this. So not colliding will be given by 1 minus this. So that is your probability for this. Now pt and minus pt, we will just simply solve this and find the value of pt now. So this pt will go this side and this pt will go this side and dt will go this side. So you can just rearrange this. This will become dp by dt and 1 upon p minus n sigma v. Now integrate 1 upon p dp and dt will be here. So it will be log p minus n sigma vt and this will give you some constant log c. From here you can see that pt will be equal to c exponential minus n sigma vt. So see, this is your probability that particle will not collide at in t time. So in t equal to 0 there will be maximum probability that it will not collide, means initially it won't collide, that is the thing. So at t equal to 0 probability must be 1. So t equal to 0 p0 equal to 1. So c we can find from here that equal to 1. Now pt, that is probability of surviving, we can say that in t time it is not colliding. So it will be e minus n sigma vt. So this c, this is exponential decreasing with time. So probability of not colliding is decreasing with time. So this is your probability function. Still we don't know if it is true or not. We will just verify later. Probability of surviving up to time t, that is not colliding, is given by this expression. So remember this. Now probability of surviving up to time t is this, and it will collide after t in dt time. That will be given by this. Not means not colliding up to t, then it will be colliding in the subsequent dt time. So that will be n sigma v dt. We came from here. So that is just use the independent events probability. Just multiplication of these two will give you a probability of not colliding up to t and colliding in the dt time. So we get this expression for the collision in the dt time. Now let's check if this expression actually gives us the probability or not. To check, we will integrate this from 0 to infinite time, and that must be equal to 1 because it must collide at some time. So to check if it is a proper probability, let's integrate this. This must be came out to be 1. So let's check. Integrate this. This is n sigma v is constant. It will give you exponential minus n sigma vt dt. So integrate this. It will be exponential minus n sigma vt divided by minus n sigma v will came out. Now this will give you minus 1, and putting infinity will give you 0. Minus 0 will give you 1. So it will be minus plus 1. So this is your perfect probability function because this is came out to be 1. Now we are sure that this is your probability. Now if you get that this is your perfect function, now you can calculate anything, means average time, average distance, anything using this function. So how can we do that? We need to calculate the average time. So we know how to find the average of any unit, any quantity. So that quantity multiply the probability of that quantity will give you your average. We already studied in the Maxwell-Boltzmann speed distribution. So for time it will be t multiplied with this complete function, and integrate for the complete time. This will give you your average time. So this is your constant will came out. Now this will be use the integration by parts. So first function is t, second function is this. So first function integrate second function, put the limit 0 to infinity minus differentiation of first function, integration, then again integration. So this will give you 0 as at infinity this will be 0 and 0 will give you t0. So this will be 0 completely, and now this will cancel out. This will give you plus 1 outside. Now integrating exponential minus n sigma vt dt will give you 1 upon n sigma v. So this is your mean scattering time or the relaxation time. You must remember this result, very important. And we also call it as mean collision time equal to 1 upon n sigma v. Now you have mean collision time, means this is the time before first collision. So you can calculate the distance also, because distance is nothing but speed into time. So speed is, we know here in the means in this zeroth order approximation we are assuming only the considered particle is moving. So average velocity must be equal to v. So that's why it will be just v multiply this. It will give you 1 upon n sigma. That will be your mean free path. But that is not the exact result. Means mean free path in the zeroth order. In zeroth order only, it will be v tau and v average is equal to v, because only one particle is moving with the speed v. It will give you 1 upon n sigma. So this is the average distance between the two successive collisions, that is mean free path. So here we used average equal to v under the zeroth order approximation. but this is not the case actually, because all particles are moving. That's why we'll study the first order approximation. And also you can must remember for this also, this case also. So here we can just change this result in the different form also. If the molecules are in the ideal gas situation, then PV equal to NKT, and from here N by V equal to P by KT. N by is nothing but this is the number density, that is N equal to P by KT. So substitute in place of N P by KT, so you will get this KT by P sigma. Now you have the relation of mean free path with the temperature, and here sigma is nothing but pi d square. So and P is pressure. So you must remember these results. In the next lecture, we'll see what is the first order approximation. That will give you the exact result. Then we will get some factor also here, 1 upon root 2 something. That will be the exact result. So that's it for today. Thank you everyone.